We are looking at lesson 76 today. We're going to look at using substitution and elimination in the same problem. And then we're going to look at negative vectors. Whenever you want. Oh, you can take it Wednesday and then do corrections Wednesday if you want. Yes. All right, so what's different about this compared to what we've done in the past?
It has another letter.
Yeah, it's a 3 by 3. Three variables and 3 equations. So we're going to use both elimination and substitution to solve for x, y, and z.
We're going to insert x on
You could do that. You could do that. But then again, you could also do something.
And then once you do that, you just use elimination. I think I'm right. I'm probably wrong here.
Yeah. Yeah, there are 3 variables and there are 3 equations. No, we'll have an x, y, and a z. It will be in coordinate form, but it will be x and then y and then z. No, he hasn't. Okay, so now what would we do? Okay, instead of x, I can put in 2y. So I have 2y plus y plus z equals none, which is what? Okay, what else can I do? Put it here. I have 2y minus 3y, which is what? Do you see how that works? Oh, it should be minus. Sorry. Thanks. We already got the wrong answer. So now we have this equation and this equation. What can we do? Elimination, or you can do substitution, either one. Solve it for y or z. Yeah. Okay, so what do you want to multiply which equation by? Okay, either way, it doesn't matter. Multiply this one by 2, so you'd get what? And then we have our other equation. You see how that works? Now what? Do you see how that works? Okay, now what? From this one, what does x have to be? Okay, now what? Plug it in here. Do you see how that works? Does that make sense? Okay, so the way that you write these, they're a point, x, y, z point. So what is our x number? What is our y number? And our z number? That is your actual answer. That's what you will write. This is, okay, so you know you have your XY graph, right? Paige just might be very difficult for her to understand, but your XY graph has another line that goes through the origin. It's called Z, and it makes it 3-dimensional. Because XY is just like a flat thing, right? And then, like, if you have This is the plane. If you have another one going here, then you can go out or backwards or whatever. So instead of just being like over here, you can also come out here. So what this point says, you start at your origin, you go right 4, you go up 2, and then you come out 3. So it's like over here compared to where the origin is. Does that make sense? I'll draw it. It doesn't. No, you. Yeah. Well, I mean, you can. Yeah, it makes it 3-dimensional, but you can't really see it because you're looking at it too. Just like a box. If I draw a box. I mean, now you can see that it's more 3-dimensional, but it's still like it's not 3-dimensional because it's only on the paper. It's the same thing with the graph. Does that make sense? Rectangular prism. You just draw them further apart. That's all I did. Anyway, any questions here? Okay. So see if you can do this one.
You messed it up. One of them doesn't equal something anymore.
But you can make it. Yeah, that's why these are the problems where I started putting a dash through my z's, because my z's and my 2's started looking alike. Yeah, that's why I started doing the little dashes, little lines through my z's.
I just make my 2's like that.
I don't always do 2's like that. No. I don't know if these are whole numbers or not. Okay, that's what I got. That's what the book got, so that's right. Okay. Did you start by saying x equals 3z?
Yes.
Okay. Did you plug it into these two equations?
Yes.
What did you get 2y plus 5z equals 12? Okay, did you get negative y plus 11z equals 21?
Yeah.
Okay, and then you multiplied the bottom one by 2? Did you get negative 2y plus 22 equals 42 when you multiplied it by 2?
Yep.
Yeah? Okay. Negative 2y plus 22z equals 42.
Is I looked at that. Wait, I don't know.
Here is where I am.
Yeah, me too, Mom.
That's a good thing and a bad thing.
Oh,
It's good that you know what you're doing, but bad that you're not adding correctly.
I was looking at 11 and it was a 12.
Okay. Instead of 54?
That would
Okay. Any other questions on this one?
wait, let me make sure.
Okay. Y'all see how these work? Not too bad yet, right?
Yeah.
Eventually they'll make it where they're all three like this. Yeah. Instead of where you see how this one only has x and z? Eventually all three equations will have all three variables. That'll be later. So make sure you understand how to do these. Yeah, you'll do elimination twice. Any questions? Okay. All right. We've done ones like this before, right? Someone go draw 3 at 45 degrees. Do you agree with this picture? 3 and 45 degrees in the first quadrant? Okay, what about negative 3 at 45 degrees?
Go left. I would think it's like opposite, right?
Okay, then go draw it. I don't know what, I don't know what, I mean, you might be right. I don't know what you mean by complete opposite. So just go draw it.
Wait, why?
Negative 3 at 45
That
degrees.
it's like
Don't draw my
negative 3.
phone you.
Close, yeah.
That little 40. But you can read that.
All right, so you start by drawing your normal triangle, but this is a negative 3. Do we like having distances as negatives? So to make it a positive, you shoot it through the origin. So it comes right over here.
I saw a negative 45, so I was like, wouldn't
Oh, no. So this angle is 45. What is this angle going to be? It's still a 45 degree angle. The angle doesn't change, but it's the angle didn't change. But now we have a positive distance instead of a negative. It's like saying I'm going to go negative 10 miles west. Instead of going negative 10 miles west, what is that the same thing as? It's the same thing as going 10 miles this direction. And that's what these pictures are showing. Does that make sense? Okay, let's try another one. Someone come draw 5 at negative 60 degrees. Okay, go try it. Go try. No, go try.
Taylor, get your blood up and put your mic.
Just go try it.
Let's go, Taylor. Let's go.
And there was like, more like this.
Okay, so if it was positive, where would you go? Okay, so if it's negative, you go. No, you go that way.
That's what I do with the negative. Go with this 60.
Because if you're positive, you're going this direction, and if it's negative, you go down. Does that make sense? You always start on the positive x-axis side. So you either go up if it's positive or down if it's negative. You see how that works? Do you agree? Oh, I was talking. The green part, ignore the black part. Okay, someone go draw the second one.
I did.
Okay, Molly. Where they say? Who's saying?
Do you agree? So if it's negative, what happens to your vector? It switches, goes through the origin. Any questions here? Okay. So now we're going to add them. We've done problems like this before, right? But we haven't had a negative vector.
Math.
Well, you get better at them, and so you can do them a lot faster. You get no. You should learn shortcuts just from doing them. Well, but if I teach you the shortcuts, then you may not understand them completely.
I'm not good at shortcuts.
Asians teach math in easier ways.
Do what?
They teach easier ways to teach math.
Oh, I don't know.
I want to say Asians, they're smart.
I would ask an Asian who takes math the Asian way. So
it's lines. That's what I'm trying to figure out. Like,
all right, someone come draw this -4 at -20. Okay, go ahead. Yeah, you can draw both of them if you want.
Okay, I'm gonna do one in one color and the other in another.
So check your graph whenever she finishes to see if yours matches. Y'all agree?
Wait, I had one. My buddy. Make it 20, so it'd be. I gotta like. I have.
Okay, what does this look like?
It's 4. Like it looks like that. Oh crap! Oh crap! Oh my god! I didn't see that -20. Oh my god! Leave me alone.
Okay. Okay, good.
I just.
Now, do you agree? Yeah, it's supposed to be a 4 and a 20. Yeah,
I
it's
don't think I forgot that one.
okay. So we want to graph without the negative. How do you graph 4 at -20? No, it's this one. Does that make sense? Because it's a -20, you go down. And then since it's a -4, you shoot it through the origin, and now it's a +4. Do you see how that works? Okay. You can do the other one. Do you agree with that picture?
Yeah.
Any questions on the two pictures?
So other than that, we do the rest the same.
Yeah. Do they have both answers? Do they have two different do they have R and U, or do they have it in vector form? I prefer it in vector form because that's what they give you it as. Does that make sense? Yeah.
Okay, like, you know how when we add them, you get R and U. I'm asking if you want the R and U form or the vector form.
Yeah. I have both on my test. Okay, someone come write the R and U for the red picture, the one on the left. Do what? Yeah, you're still using cosine and tangent, just like before.
Yeah. Do what?
That's just one of those haunted houses.
Drawing? Let me one of those dolls.
Wait, do we have to put it back in forward form once we're done?
Yeah. Do you agree with that? Why is the R negative? Going left. Yeah, we went left and then up. Okay, someone go write the other R in U for the blue picture, the one on the right. Yeah, you can go ahead.
I don't know how to find what fraction of a square.
Whoa, I ain't this word.
Let me see. Where'd you get that number?
I might be wrong. Is it wrong?
It should be 5.
Huh?
You did 4 cosine.
Is the R is wrong?
Yeah, the R.
Cosine is R, right?
You did 4 instead of 5 cosine.
R. Right.
You used a 4. It's a 5.
This
Yeah, your R. Yeah.
Oh, that's how I got this right. I thought it was the same.
Yeah, they are. Do y'all agree with those two numbers?
Yeah.
Now what?
You add them.
Okay, someone go write the resultant. Someone else.
Sean, go to the board.
What we do have right?
Adam. No, you go to the board. Why are we?
You're already up, so.
No, I should be.
You're already up.
I just win.
You're already up.
No, I just win.
No, somebody else go. Hang on.
See. Sean.
Emily hasn't been writing it down, so that's why she can't go.
Oh, it's 3. It's 3.
Yeah.
Let's go, Sean. Let's go.
Do I have to show the work?
I would, so you get full credit on your notes.
I just write down so I have to show.
No, you don't have to show your work. Just add them together. Is that how you write it?
No.
Well, those weren't written like it. I just wrote like
No, we were just writing what our R and U's were.
Sean. Okay, now, is that a 7 or a question mark?
It's a question mark.
That's really crazy.
Do you agree? All right, how would you change it into vector form, back into like this? Okay. Where does it get drawn? Okay. 7.3 and then up 4.91. All right. H. Hypotenuse. What would you get for your hypotenuse? Yeah. I agree. How do we get our angle?
Never worked.
4.91 over 7.3. Opposite over adjacent.
What do you do when you get that?
I got 33.
Yeah. Do you get 33.92?
You have to use parentheses when you put the calculator.
Not really.
I do.
Yeah, you might have to. Yours is different. So, how do I get to this angle? 180 minus that angle gives you that vector. So 8.8 at 146.08.
I still got the answer. I just did the long way.
Yeah, that's fine. Any questions here? Any questions about the negative vectors?
Is there any more practice you to say no?
No, that's it.